This is a video on the interval of convergence. The question states, find the interval of convergence of the summation from n equals 0 to infinity of negative 1 to the n times x to the 2n over n plus 1 factorial. So I'm going to use the ratio test, and the ratio test tells us to take the limit as n approaches infinity of a sub n plus 1 over a sub n. So a sub n plus 1 is found by just plugging in n plus 1 for each of the n's in the term, and a sub n is just writing down the terms. So now let's simplify a bit. N plus 1 is just n plus 2, and 2 times n plus 1 is 2n plus 2. And when we divide by a fraction, we can multiply by the reciprocal. So what I'm left with is a limit as n approaches infinity of negative 1 to the n plus 1 times x to the 2n plus 2 times n plus 1 factorial over n plus 2 factorial times negative 1 to the n, x to the 2n. So now let's regroup. Let's put the negative 1 to the powers together, the factorials together, and the powers of x together. And I've done that. Now notice that I have absolute values, and absolute values always kill the negative 1 to any power, so those just go away. Also, x to the 2n plus 2 over x to the 2n, I can use the rules of exponents that says I subtract the powers. 2n plus 2 minus 2n is just 2. And I'm going to expand out the two factorials. And what I get is n plus 1 factorial is n plus 1 times n minus 1 times all the way down to 2 times 1. And n plus 2 factorial is n plus 2 times n plus 1 times n minus 1 times all the way down to 2 times 1. Remember, the negative 1's went away, and the x to powers became an x squared. So now I can just cancel. The n plus 1's cancel, the n's cancel, the n minus 1's cancel. The 2's cancel, the 1's cancel, everything cancels except the x squared is left. I'm left with just a 1 in the numerator if everything cancels. And the n plus 2 never cancels, so that's going to stick around. So I'm left with the limit as n goes to infinity of 1 over n plus 2 times x squared in absolute values. Now, x is just a constant for this limit since the variable is n in the limit. So I can just plug in infinity, and I just get 1 over infinity times x squared. 1 over infinity just goes to 0. So what I get is 0 for the limit. I'm using the ratio test, and for the ratio test, we want to look at that limit and to see for what values of x is our limit going to be less than 1. Well, 0 doesn't have any x's in it. In fact, the x just went away when we took the limit, which means that 0 is less than 1 for any value of x. So in particular, we can say that the radius of a convergence is infinity because this converges for all values of x. And we can conclude the series converges for all x by the ratio test. The interval of convergence is from negative infinity to infinity. And I'm done with the problem.